So maximum response is a vector. At different locations, we have a different maximum response because this is a vector. So if you want to obtain the response at the top, you just need to take a value of the model ship at the top location. Okay, if you want to obtain the full story, you just need to use the value of this model ship at the full story. Okay, so this is a false measure. This is a SRSS. We use a formula given here. Just want to obtain more reasonable maximum response. That's all. Okay, more reasonable. We can achieve a reduced response. Okay, so this is more convenient, more reasonable for design. Okay, for the design. And this is another formula. This is too complicated. Okay, I do not recommend. Okay, but in the design, in the program, in the design, in the final element program, maybe some final element program recommend different measures. Okay, not just SRSS and also CQC. You just need to understand, okay, we use a different measure, just want to obtain a reasonable maximum response, okay, contribute from different modes, okay, contribute from different modes. So in this way, we can obtain the maximum response, okay. So here I provide you one example. This is according to the China design code, okay, so this is Chinese design code. They only use one curve, design curve, and they just obtain the acceleration spectrum acceleration response. They don't have a velocity displacement, okay, but you can transfer acceleration to velocity, acceleration to displacement, okay. So this is a formula. The maximum response, okay, so I provide you. In this case, we consider two-story building structure, and we know the mass for different floors, and we know the EI value for different columns, and based on the eigen and the characteristic analysis, we can obtain the frequencies for first mode and for second modes, as well as corresponding model shapes. Okay, so we have done in the previous lectures, okay, we have shown you how to obtain the frequencies and the mode shapes for different modes for any multi-degree freedom system. Okay, so after obtaining the frequencies and the mode shapes, and of course you have to assume the damping ratio. Okay, so we use the design response spectrum given from the China design code. Okay, so we try to obtain the modal response spectrum, acceleration, pseudo velocity, and the pseudo displacement, because the China spectrum only provides a spectrum acceleration. So you have to obtain the velocity displacement based on the acceleration. So this is so-called pseudo velocity and the pseudo displacement. Okay, acceleration is a true value, and the velocity is based on the approximate relationship. So it's called pseudo. Pseudo means approximate. Okay, and we can obtain the response for the first mode and the second mode. Okay, and then we can use SRSS method to obtain the total response. Okay, according to the China design code, the acceleration spectrum is calculated by use this formula. Okay, so this is a maximum response. This is a maximum response, and this maximum acceleration is equal to alpha times g. G is a gravity acceleration, and the AT is a function of the natural period. Okay, for the first mode, T1 is equal to 1 over F1, right? Because T is a reciprocal of the frequency, so T1 is a 1 over F1. And for second mode, T is equal to T2. T2 is equal to 1 over F2. Okay, so this is and this is so-called seismic effect coefficient, because G has the same unit as acceleration response, right? G is a gravity acceleration, so it has the same unit. So this is a dimensionless. This is a dimensionless factor. Okay, and this is a normalized design spectrum. Okay, and the maximum value of the seismic effect coefficient is equal to 0.24. This value is different for different zoom, intensity zoom. Okay, so from the design code, okay, design code can tell you how about this maximum acceleration values. This is like I mentioned, okay, for different size of intensity zoom, they have a different alpha maximum value. Okay, so in Hong Kong, okay, even for the region in Hong Kong, this value is provided, is available. Okay, and then okay, as I mentioned before, because the spectrum depends on the site condition, depends on soil condition. So we have a second parameter. This is so-called the characteristic period of the site. Okay, so for different soil condition, we have a different TG value. Okay, and again, this TG value is available from one table giving the design code. So for different soil conditions, soft soils, different soil, we have a corresponding TG value. So TG value is available. Okay, and we also needed to calculate 3 parameters. Okay, these 3 parameters are function of the damping ratio, just damping ratio. So when the damping ratio is provided for the structure, we can obtain these 3 parameters, but it is not necessary. I will show you because we obtain 3 values just for convenience of the alpha value. Okay, you can measure the alpha value. For example, when for the first mode, when F1 is given, we can obtain T1. So if T1 is here, you can from this curve you can obtain the value about this alpha, right? But this curve has been also represented by this function. Okay, so if you obtain the parameters, you can calculate this alpha value, but it is not necessary. You can measure the distance as alpha value for this range. Okay, and for this range, okay, alpha can be obtained, okay, by measure the distance from here, and also can obtain alpha for this range based on this formula. But if you want to use a formula, you have to obtain the 3 parameters. Okay, this one, and this one. Okay, so they are just a function of the damping. So here there are 3 parameters. Okay, and for our problem, we assume the damping ratio is equal to 3% for all modes. For different modes, they have the same value. Okay, same value. So and then we can go to the design. Firstly, for the first mode, okay, so we just need to consider 2 modes. Okay, so for the first mode, we have obtained the frequency, so we can obtain the T. Okay, this T. T is equal to 0.84. Okay, so how about this value? Which range? Which range? Based on the damping ratio, we obtain this value. And TG, how about TG value? TG is 0.4, and this T is larger than TG, right? Is larger than TG. So, but please compare this value. How about 5 TG? TG is equal to 0.4. Okay, so this value is larger, also large 5 TG. So it's between this range. It's between this range. So you can use this formula. Okay, so firstly, we obtain this coefficient and this coefficient, and then we use a formula given here. You use a formula given here because the period T1 is between TG and 5 TG. So we use this formula. If larger than 5 TG, we use the second formula. If less than TG is equal to a constant value, is less than 0.1 second, we use a linear interpolation. Okay, so in this case, because T1 is range between TG and 5 TG, so we use this formula to obtain the alpha value. Okay, after obtaining the alpha value, SA1 is equal to alpha times G. So we have obtained the maximum acceleration. And then based on the pseudo relationship, we can obtain the maximum velocity and the maximum displacement. Of course, when we consider first mode, we use omega 1, right? So it's very simple. We have obtained, okay, some maximum acceleration and the maximum velocity and the maximum displacement, but they are just spectral value. It's not physical value. Okay, they are just spectrum value. Okay, spectrum value. And then for the second mode, okay, F2, based on the F2, we can obtain T2. And this T2 is less than Tg. Okay, T2 is equal to 0.35, is less than 0.4. Okay, so this value is between 0.1 and the Tg. So this is a constant value. So you just need to calculate the second parameter so we can obtain. So for the second case, because this parameter is just a function of damping ratio, and for the second mole, we assume the same damping ratio. So this parameter is same as this parameter. If we use a different damping ratio for different modes, you have to calculate the second parameter based on this formula by using the damping ratio corresponding to the second mole. Okay, so we have obtained the alpha value, and then we obtain the acceleration, velocity, and displacement. Okay, so now I provide a question. Okay, so we have obtained the modal response, maximum modal responses in terms displacement, velocity, and acceleration. Okay, so please try to obtain the total physical response. Okay, total physical response. Of course, when we use a total physical response, we have to calculate the participation factor. I already provided the participation factor for the first mole and the second mole. So please try to get the solution. Actually, you just need to use the formula given here. Okay, this value has been obtained. This value has been obtained. This value is given. So we can obtain the maximum response. If you want to obtain the displacement, please use SD. If you want to obtain the velocity, please use SPV. If you want to obtain the maximum acceleration, please use SPA. Okay, so in this way, we can obtain the total response. So, okay, you know how to do the seismic design based on the China design code, seismic design code. Okay, so it's not so complicated. It's not so complicated. Okay, so we can obtain the maximum response, but you have to, for multi-degree freedom system, usually you just need to consider 3 to 5 modes. So you have to calculate the 3 to 5 modes, okay, based on the obtained frequencies and the mode shift. And then we can obtain the modal response, and then you can transfer to the physical modal response, and then to the total maximum response. That's all. Okay, so that's all. So here as a last step, I ask you to get the solution for the last step by yourself. Okay, please try to obtain maximum x1 and maximum x2 for the first floor and the second floor. Okay, and also we have a